Hey, so now we'll be looking into the 21st problem in the Leetcode, that is merge to sorted list. So this is basically a very simple problem. There are two sorted lists. Let's say this is the example 1, 2, and 4, and the other sorted list is 1, 3, and 4. So here we basically have like let's say this is the problem, right? So we are given with the two list node heads, that is list 1 and list 2, which are basically pointing to the each list head respectively, right? We basically have to compare these values and basically merge those two linked lists into a single linked list, which is totally sorted. Okay, so how are we gonna do it? So one brute force way will be basically to store the values of this linked list inside a array. Basically, we have to traverse the list. Let's say first list one, uh, traverse through the list. Okay, we put those values inside an array value, and then we basically traverse to the array, compare both of the array values, and then basically create a new list node and assign the value of that node that val equal to the array value. And that's how we basically create. But that is really inefficient because first of all, it will be taking like off and time complexity, right? But space will be also be taken. We are taking extra of n plus m space where n and m are basically the size of the linked list L1 and L2 respectively, right? So what can be the better way, right? So the better way is basically to combine the linked list while we are traversing and while we are basically comparing both values of that list. So we have to traverse both of this list, right? Let's say L1 and L2. But while traversing, if we lose the values of this head, okay, let's say we are using L1 for travels, and eventually this L1 will go here, here, and here, then L2 will go here, here, and here. So we'll be losing the values of the actual head of the both the linked list. So what we can do here is basically store the values of the head in a dummy variable, right? So let's say we create a new variable. Okay, we'll store any random value. It's a zero. It doesn't matter because it's just a dummy variable, right? So now what we're gonna do is basically we are going to initiate a loop, a while loop, where we'll be checking if L1 reaches the end of the list or L2 reaches the end of the list. And if one of the list it reaches, then we'll just combine the rest of the list as it is to the final appended list, right? So so let's start by comparing the initial values, right? So L1 dot value and L2 dot value will compare, which is lesser. We'll just assign that value to a new to will basically not assign, but basically we'll just point the domain next to that node, right? So the L1 basically the L1, I'll show you the code, right? So basically the uh here we are just comparing list of value which is less, right? And the current value will be basically here, right? In the dummy. So this is a temporary variable. Also, we'll be using another variable called as c. So we'll be doing c dot next. Okay, c dot next will be L1. Okay, just it's similar to here. And then we'll just move this L1 pointer, right? We'll move this pointer from here to here, right? So we are traversing, but again, just keep in mind we are not losing the track of this because eventually, yeah. So after this while loop, we'll also move our c pointer to the next value, which is here, right? And we'll remove it from here. So if you see technically, we are not using the value of this head because dummy will always be pointing to the head. If you want to return the value of the head, we can just do dummy dot next, return dummy dot next, right? So now we'll compare these values. The L2 value is small, right? So the L2, so see current dot next will point to L2 value. So here is the L2 node. This current dot next will point right over here. L2 will now move to the next node, which is here, right? And we will also move our current pointer to the next pointer. So that's how we basically move uh, one by one. We are comparing both the lists simultaneously. So it's basically like a merge sort where we are merging both the arrays and we are sorting it one by one by comparing each element at one time, right? So since we have a dummy node, we don't have to worry about any of the head changes. We can just append it easily. And eventually, once one list has completely traversed, we'll move on to the second list if there are any elements remaining right over here. We can just append those elements directly in our final list, right? So yeah, so this is basically the code. So this is the while loop, right? So we just discuss if the list one value is um, lesser than um, we basically assign that value to current dot next and then move the list pointer to the next variable. Same will do for the list 2 as well. And then move current pointer at the end. We'll do this until it is the end of the both of the list. Now, once our first both the list, let's say our list is over right here, okay? So for the last values, let's say there are some values remaining still. So one of the values is reached to the, let's say, the null value, right? So one of the values is reached over here. So the loop will be terminated because it's L1 and L2. So this loop will be terminated. So how do we actually access this rest of the values? So for that, we'll check if L1 or L2 are null. So in this case, L2 is not null because it is storing some value of this node, right? So that's the reason we can check if any of the value of are null. If they are not null, that means that's the list that's still remaining, right? So what we can do is basically we can do current dot next equal to L2, and we can directly point the rest of the list to the remaining part, right? So that only we have done. So current dot next equal to list one or list two, depending upon which list is remaining, right? Which has some values, and we are just returning the dummy dot next leg. As I said that because that dummy dot next basically is pointing to a new head, right? So yeah, so that's it. Uh, uh so this approach basically takes O of n time because we are traversing both the list, right? So sorry, O of n plus m, where n and m are basically the size of the list, L1 and L2 respectively. And for the space complexity, we are not basically using any space complexity, so it's O of 1. So yeah, that's it for the video. Yeah, thank you.